Fine. I am going to start. It's almost 10 o'clock. I am going to start. In the last two lectures, we had built a case for solar DC. The basic case is the appliances are far more efficient when they are DC, and the world over there is a move towards DC appliances. Alright, fine, good. Alright, fine. So we had already pointed out that using most appliances at homes are becoming DC, and they are far more energy efficient. So whether it is a lights or a fans or television or computers, laptops, or even things like mixers, grinders, refrigerator, all are gradually using DC because they are all becoming electronified. They are using LEDs, they are using DC motor, a brushless DC motor or SR motor. They are using all the electronics, which are all DC. So essentially homes no longer have AC. If you take, and every appliance will require a AC to DC converter. Every converter, AC to DC converter, would imply losses, would imply cost and a reliability problem, because that is more likely to fail depending on AC variation. If you put a DC line, then it works very, very well, because now all these things can be powered with DC. I will argue that we can use a DC wire line at home at 48 volt, and you can power all of them. Of course, not everything will use 48 volt. You will require DC-DC converter, but DC-DC converter have less losses. Do not have a problem once you use DC line at homes. The power factor issue does not come up. Otherwise, remember that every AC appliance, when you take a AC line and you put a converter in every appliance, there is a power factor issue. If you do not design it well, the power factor will be bad. Now, if you use DC line, there is no such issue. So, much cleaner, nicer. Appliance is one reason we like to move to DC, but more important, solar. If you want to directly connect a solar to this line, and this is what we will today learn how to do that. Solar gives you DC power, it is so much easier to connect directly. If you want to use a battery backup of any kind, lead acid or lithium ion, whatever battery backup you do, it only takes in DC power and gives you out DC power. So it becomes much better if you use a DC line. So what I am going to argue is, let us have a DC power line at home and offices. Transmission can remain AC because we do not want to change it overnight. At the entrance of the home, that AC power line is converted to DC. That is where you take care of a single converter. You design it well, make sure that power factor is taken care of. At that point, losses are minimized. Beyond that, keep everything DC. Hook solar directly to this, hook battery to this, and hook appliances to this. This is what I will argue today. Power cuts and solar DC innovation and UDC innovation. Even as India moves away from power deficit situation, 3 years back, 5 years back, there was a heavy power deficit. In last 5 years, there has been continuous improvement. 4 years back, we had less deficit. 3 years back, we had even less deficit. 2 years back, almost deficit disappearing. Now we are a little bit power surplus. Indian power scenario, however, is such that 50 million homes are still not connected to the grid. And this is a very big dilemma. You have power because they are maybe somewhat remote. But what is most important is that 50% of India's home cannot afford power even at subsidized rates. And that is the reason, if you draw a power line to a particular home, you just do not earn anything, you lose money. Because you lose money, DISCOMs are reluctant to do that, and that is part of the reason why almost 50 million homes, maybe have gone down to 45, but not more, less than that, still not connected to the grid. About 100 million homes still have load shedding. There is a very interesting work, if you are interested, please take a look at it. There is an organization called Prayas, P-R-Y-A-S or P-R-A-Y-A-S, I don't remember, Prayas, P-R-A-Y-A-S as far as I remember. This organization has put monitoring stations in every district of the country. It just monitors when the power is there, how long the power is there, randomly it has placed it. It monitors what is the voltage, what is the voltage, what is the frequency, and whether power is there. And you will see most places, in spite of government telling us the power failure doesn't take place, most places have power cuts. In cities slightly less, as you go away to rural areas more and more, smaller towns there is lot, and there are in some states where the power cuts are very, very bad. Whatever be the reason, there are power cuts, whether it's a load shedding or power cuts, so that continues to be an issue. So what I was pointing out, that most people in India, almost 50% of India's home, cannot afford power. Their ability to pay is very little. Tariff hikes are socially resisted. I don't know whether you saw the news 2 weeks back, not 2 weeks, last week, Bihar doubled their tariff, doubled their tariff. It was very low. It was some 2 rupees something for the first 50 units. It made it something like 5 rupees something, more than doubled it. And there was a resistance. Now it has reduced the hike. So it is somewhere in between. But the point is, high tariff hikes are resisted. Many homes cannot afford to pay more than 100 to 200 rupees. More than 100 to 200 rupees is not easy. And the question is, how much do they consume? If I look at 2015 number, I don't have the latest number, total domestic consumption was 2000 terawatt for 1.25 billion people. An average of 500 watt hour per day per person, or 2.5 kilowatt per home per day. That was the average. But 2.5 kilowatt average, there are people who use air conditioning, etc., and consume much more. So when they come in, even if you take that they don't have power, many of them don't have power, it is 4 kilowatt hour per day, and many of them do not have more load than 100 to 500 watt hour peak load. Most lower income consume even less. They consume about 100 watts per day and in the peak time. Some upper income group and home appliances and some multi-story apartments use diesel generator. When power cuts takes place, many of these places use diesel generator. Some of the colleges also will use diesel generators. Cost of DG power is 4 to 5 times the cost of grid tariff. Grid tariff is about 5 rupees, 4 rupees to 5 rupees per unit. The use of diesel generator is 20 rupees or even higher, and still we use it because the money is there. In the institutes we use it. Some middle and lower class, lower middle class homes use inverters. That means battery, and we will talk about this. But even this is very expensive in the current way. The AC is converted to DC, then it is charged batteries, then it is taken out. It is still about 3 to 4 times. So for the power, we may pay 5 rupees or 4 rupees for the grid, but when we get it from the inverter, our effective cost, if you take the interest and the depreciation of the inverter also into account, is about 16-17 rupees. We still pay it because that's the only way we get power. Many others don't, just suffer. They don't have inverter, they don't have generator. And we are going to look at how they are done. Let's look at how are the inverters designed. Inverter, most of you have heard of inverters. Do you have inverter at your home? Can you raise hand? Basaveshwar College, how many of you have inverter at your home? Only 6 of you have inverters at your home. The rest of you do not have inverter. All those who have inverters, please raise your hand. Please raise your hand if you have inverter. Yeah, I see about 10 of them. The others, when the power cut takes place, that means you just don't have. You may have a diesel generator. How many of you have diesel generator at your home? Most of you do not have diesel generator. So how does this inverter works? Let's look at this. 230 volt AC comes from the grid. The battery can only be charged using DC. So typically this 230 volt AC, there is a AC to DC converter, typically 48 volts, sometimes 24 volt or 48 volt, and then you charge the battery. There is a AC to DC converter. This is charging that is going on when the power is there. When the power is not there, this line, instead of directly this being there, this is switched to the output of this. You again have a DC to AC converter. Now what happens that these DC to AC to DC and DC to AC converters are very inefficient, because you have basically small inverter. Your inverter may be 1 kilo kVA inverter or even smaller. If you have 1 kVA inverter, your losses will be of the order of 15%. 15% losses here. If you have, of course, 5 kilovolt inverter, the losses may be more like 7-8% kVA inverter. But most homes will have 1 kVA or 1.5 kVA, in which case losses will be 10 to 15%. So it will be 10 to 15% losses here, 10 to 15% losses here. Of course, you use battery also has about 10% losses. So you will land up about 40% losses. So, and if you take even smaller, like 100 watt to 500 watt VA, 500 VA, there is a 700 VA inverter, the losses will be even higher. So most batteries at home are less than 5 kilowatt hour. In fact, average battery will be about 2 kilowatt hour or even 1 kilowatt hour, 1 to 2 kilowatt hour. So that's what it is, and the cost becomes very high because of the losses. Of course, the cost of the battery has to be included, plus cost of the power lost due to this, plus power loss due to this converter. So this is what you today do in the inverters. How do the grid synchronized, will rooftop solar PV help? Now today there is a program that you can get rooftop solar, you can connect it to the grid, and it is a grid synchronized inverter, and then you get a 230 volt AC solar plus grid power. So once again, what happens, from solar DC it converts to AC, it synchronizes to this 230 volt AC. Now depending on the size of the panel, if you are using half a kilowatt hour of panel, 500 watt panel, the losses will be about 15%. If you use 10 kilowatt, the losses are more like 4 to 5%. But most homes use half a kilowatt or a kilowatt, the losses can be 15%. And then it is grid synchronizes and this gives you power. So this is the way solar is connected. There is losses and because there is a DC to AC converter. Typical inverter has 97% for, well, 97% is tough for 10 kilowatt. You get at least, but 95% is very much possible. But if it is a 200 watt or 300 watt or even 500 watt, this is a 15% losses. That's a point that I am making. But what is the problem with this solar rooftop? Many homes have put this. The solar rooftop in itself does not give you power when the power fails. In fact, they are all designed that as soon as the 230 volt AC power fails, this shuts down. This is something very peculiar. So the solar can give you power only if grid has power. Grid doesn't have power, solar doesn't give you power. Now this is very peculiar. Why is it designed? You know, your demand, your usage will vary from time to time. It will not constant. Now if you had grid has infinite source. You can draw whatever you want. You can draw half a kilowatt or 1 kilowatt or 1.5 kilowatt. You turn on a light, turn off a light, shut off a television. Power changes, but grid can draw whatever you want. Now as long as grid is there, grid is an infinite source. Solar is a fixed source. Depending on the sunlight, it will give you a certain amount of power. Either you consume all of it, exactly all of it. You have to consume all of it, exactly. Now it is very difficult to match the load to the solar if the grid is not there. Of course, if grid is there, grid plus solar has to match the demand. And grid you can draw less power or more power from the grid and there is no problem. Whatever is from solar, you use it, balance you take from grid. But as soon as grid shuts off, you cannot do this balancing, and therefore the solar is also cut off. The inverters are designed to cut off power when the solar is not there. This is a very interesting thing. In fact, when the floods took place in Tamil Nadu, you probably have heard in 1980, about 2 years back, 2015 December, there were 4 days there were floods such there was no power at all. We had 1 megawatt rooftop in IIT. So sun was there, so power was there, but that was shut off because it was grid synchronized. That all the solar installation are grid synchronized. That's what happens. So solar PV cannot help us in itself to do power cuts. Solar power is available only for certain hours. Of course, that is one problem. But if grid power fails, when sun is not shining, one will be without power. Even if the grid power fails, when sun is shining, you will be without power. because grid synchronized inverter shut down output when grid fails, even if sun is shining, because otherwise you'll have to match this exactly. So the solar comes in here, the grid comes in here. The minute this gets shut down, this output gets shut down. This is what it is. And therefore, if power cuts takes place, we don't get power, even if sun is there. So what's the use of this? If you want to now add power backup, you have to add power backup like this. You have to add another inverter. You have to add another inverter. This will give you power backup. But what does it mean? You have, of course, 15% losses here, assuming that you are using small solar. You have a 15% losses here, 15% losses here, and losses in the battery. So you have 45% losses plus losses in the battery. This should be one of the way you will use it. And if you go solar through the battery, you land up using almost 55% losses, 45% due to converters and 10% due to battery. It's extremely inefficient. So you suppose you have a 500 watt hour solar panel and it is generating at noon 500 watt. You will think that you are getting 500 watt of solar, but actually you are getting only about 220 watt of solar at that time. Rest is getting lost. And this is a big problem for solar with AC. Grid and solar would now charge the battery and also supply AC power to the load. During load shedding, solar and battery will feed load, so no problem. When solar is not there, grid alone will supply the loads. And if now the grid fails, battery will supply the load. But the solution has serious limitation. Solar PV power cost similar to the grid tariff, but introduction of battery quadruple the cost. And then you lose almost half the power. So solar PV power has losses in inverter and battery charger. Again, as I told you, 45% plus battery losses. So essentially in the end, as a result of it, your solar with battery price has become 6 to 8 times that of the grid price. And therefore, with battery backup in this conventional manner, it doesn't make sense. Because anyway, it would have been 3 times maybe with battery, but because of losses, it may become 6 times. That's the kind of problem that you have. So what am I talking about? Decentralized solar at home. Solar PV gives you DC power. You need a DC to AC. You have a grid connected to it. You can synchronize it. Grid can go directly to the AC load. This can also go directly to the AC load if there is power. If there is no power, then you of course have to add a battery, and now you have a AC to DC here and charge the battery. Grid can also charge the battery, and you get out of this again DC to AC, and you get out here. Look at this path. This is 45% plus the losses in the battery. What about this path? This path has no losses here, but 15% here, 15% here, about 30% plus losses in the battery. Of course, for a short period of time, when solar and grid are both there, this may be supplying power directly. That's advantageous to you. So when it supplies directly to you, the losses are much less there. But we'll look at all these losses as we go on. Why can't solar directly charge the battery? One will say, why convert it to AC? Why convert it to AC? And then do AC DC? Why this DC AC and AC DC? Why can't I directly charge the battery? Well, try that. And we have looked at every possible way. Let us look at this configuration. Here, solar is directly charging the AC, and grid is converted into AC DC. So this is done DC to AC, and then the battery is done. What is the problem with this? The problem is solar cannot be used without battery to directly power the load. What happens? It always has to go through the battery. What if solar wants to directly power the load? Suppose solar is there and AC load is there. Can it directly do that? No, it cannot. Because you have removed that. In that old configuration you could. At least in the old configuration, I will come back to it. One of the advantages in the old configuration was the solar could directly power it. At least the losses there was much less. Now, it always has to go through the battery, which means solar is horrible. Similarly, grid has to go through the battery, whereas grid most of the time could power the load directly. So you are unnecessarily adding losses and using battery. So this is a bad configuration. You will not design it like this. So additional losses. What if you do it differently? One will say, what if I move grid like here? Well, grid can now directly power the load. So that is good. The grid losses have been removed, but solar is still going through the battery all the time. So the battery losses plus 2 converter losses will always be there, plus there is more penalty. Now the grid cannot charge the battery. Suppose it is a day which is cloudy day, monsoon season, very little sun is there, your battery will run out of power. When battery runs out of power and grid has not charged the battery and grid fails, you don't have power. So again, and you can look at any of the solution. I request your classes to try out any solution other than what I had proposed earlier. That's the only one that if you remember, this is what I had proposed earlier as the only solution which will give power from solar directly to the AC power when it is there, or through the battery when solar is not there. Grid can directly give the power or through the battery when the grid is not there. But the disadvantage here is losses, and any other way to try to reduce losses doesn't help because it only may worsen the situation. So decentralized solar system, the question is, when problem like this exists, why don't you read it in your books? Why is it not highlighted? It is because most of the books and knowledge comes from the West, and Western countries do not face such a serious problem. Why? Typical home will not connect 500 watt, but they will put 10 kilowatt. In fact, 10 kilowatt, 5 kilowatt is the smallest that is put, mostly 10, 15, 20 kilowatt. Now for 10 kilowatt, the losses are under 5%. So if I go back to my original diagram, it is not bad. Through the battery when you go, it is a 5 plus 5 plus 5, 15% plus losses in the battery. So it is not as bad. In our cases, it becomes 45% because we are using smaller solar panels. One can say, can you for small power, can you not design better in converters? Well, if you design better converters, very expensive for small ones. For large ones you can do. For small ones, if you try to do it, it becomes very expensive. And most of them have rarely load shedding, so they don't have to worry about this. Even if the load shedding is not there, let solar directly power and grid can power. Grid is there all the time, so solar will not be wasted. I will tell you a little story. I remember almost 6 years back, I had gone to Ahmedabad on some government invitation, and 7 years back probably, and they were amongst the first ones to start using solar. So they took me to a big building and they said, sir, in this building we have put so much solar, it's a multi-story building and all the power is coming from solar right now, and we are in great shape and we are saving so much power. And of course they gave me all the economics of it and all that. I went through, and it was around noon. I was visiting, and it was very good. And then while I was going through, power suddenly failed and we were in dark. The building was inside was designed somewhat dark, and then after 3 minutes or so, power came back. I asked, what happened? They said, well, there was a power failure in the grid. I said, there's a power failure in the grid, but you are getting all the power from sun, and sun is still very bright. There is no cloudy. Why is sun not able to power the building? They said, that's the first time I learned. They said, no sir, only when grid is there, solar works. And I said, well, the power just came back. Did the grid come back? He says, no, we are using a generator. We turned on a generator acts as a grid. Now the solar is also there. So first time I came to know that grid is required, or a generator is required for solar with inverter to give me AC power. I asked why. Fundamentally, I asked the management, top management, see, you have such a large sun. Why did power go off at all? They did not know, but they immediately called the people who had set up the whole thing. So their engineers came while I was there. They came very quickly, and I started asking them, and they say, sir, we don't know, but this is the way the system is designed. I say, it's not poorly designed, that sun is there and you are not using it. They say, sir, but this design actually has come from Germany. We will connect you to our German counterpart. So I said, leave it, but they said, no sir, it's very important. You have raised an issue which we had not thought about. Why don't you talk to our German power counterpart? And the Germany, they made a call, and the German engineers had come in. It was around 2 o'clock, it was somewhat early in the morning for them, and I asked them that why is this happening, and they would not understand what I am saying. I said, when the grid fails, why does solar not continue to power? They said, no, but it is designed such that only when the grid is there, it can power. I said, why can't you change it? He said, why do you have to change it? Grid is always there. I said, but grid is not always there. Huh? First, they couldn't understand why grid is not there. So it took me 5 to 10 minutes to explain to them. They say, yeah, once in 4 or 5 years, grid fails. Because a grid collapses once in 4 or 5 years. And for a short time, yeah, we don't have a solution for that. I said, well, grid doesn't collapse once in 4 or 5 years. Grid fails every day. I asked the people in Gujarat, does it fail every day? So for a few minutes here and there, sometime 5-10 minutes, that time, yes, power will still fails. Why should grid fail? The Germans couldn't even understand. But then I had to try to explain to them that there is a load shedding that takes place. And then they say, but then we don't have a solution for that. And that's the time then you have to use battery backup or generator, which is the same thing. So that's the first time I really understood the way these things have been designed have not taken into account that in India power fails. For whatever reason, either is a load shedding or whatever reason power fails. Even though the places where things have improved, even there the power fails. For example, IIT, Chennai right now doesn't have a shortage, and IIT faces practically no power cuts. And yet, every second day, for a few minutes at least, power fails. And at times it goes up for half an hour, 45 minutes. So, and this is in city. As you go to rural areas or small towns, the power failure increases. And I asked you to look at the Prayas data, and you, Prajot also, you look at the Prayas data, you will see many places the power situation is very bad. And the current solar system is not designed for this. And if you do that, the way I had done it in the design, you have a very highly lossy system with battery. Either, of course, solar can directly feed, grid doesn't feed, but whenever the power fails, your losses are very. If there is no grid, you are in trouble. So what is the option? As I pointed out, in our homes, mostly the power that you use is very small. So most of us use only 500 watt or a kilowatt, and the losses are very high, and we don't have a solution. We need something different. And then something different, we thought of one reason. We now looked at, as we started looking at something different, we sort of said, well, but the world, India is moving, or world is moving towards DC appliances. I have already told you that AC fan takes 72 watts, BLDC or SR motor fan only takes 30 watts or 9 watts. A tube, instead of taking 36 watts, take 15 watts, or even at the low this thing it takes only 4 watts. And we said all electronics works on DC, and even refrigerator, washing machine, everything is becoming gradually into DC. So using DC appliances will save power by 50%. So I took that in. We took that into account and took the fact that we want solar and we don't want high losses, small solar, 500 watt, 200 watt, and we came with the solution. We came up with this solution. This is called inverterless, a solar DC battery backup system. Solar DC battery backup system. Look at this, what we have done. Grid is converted from AC to DC. It's converted to 48 volt DC. I'll argue out why 48 volt DC later on. This is combined with solar, which is also designed to give you directly at 48 volt. So you combined and directly feed the load. So grid can feed the load, solar can feed. Load is all DC. Load is all DC. The key that is missing, load is DC. You use DC fan, DC, directly 48 volt DC. And if you power fails, either this fails or solar is not there, then you go through the battery. You charge the battery, which is also DC, so no losses here, and then when it comes out, it also gives you 48 volt DC, again no losses here, so you get something like this. The losses are minimal. I'll come to why the losses are there. High efficiency usage of power. Grid power alone can be converted to AC to DC. This is the only loss. There are little bit losses Like for example, one of the problem is design is complex. Solar voltage is not constant. Remember that class that Dr. Prajot took, that solar panel has a maximum power point at which it operates. Because of that, the voltage will vary in the day. It can be 50 volts, 49 volts, 48 volts, 47 volt, 46 volt. So it varies by 2-3 volts. So solar voltage is not constant, and for maximum power it has to keep that. So this is not 48, but it's 48 plus minus say 3 volt. This is under your control. You can make it whatever voltage you want. Battery voltage will depend on the state of charge of the battery. This is something that can be taught to you by the local faculty. The battery voltage will depend on the state of charge. When it is a fully charged battery, maybe 52, 53 volt. When it is fully empty, it could be 43 volt. It's a lead acid battery. And similarly, lithium ion batteries, when they are designed, the voltage can vary. So these three voltages are not same, and this you require something like 48 volt. Now that design, there you require change. If you put a DC-DC converter instead of AC to DC converter, you'll again have those losses. Instead of 15%, maybe 12%, 10%, you still have losses. So it has to be very carefully designed, complex design, such that you operate at solar MPPT. This voltage and this voltage is made same. This you can change without much problem, because that is under your control. You make it, this one synchronized to the solar voltage all the time, and load operates with a slight different voltage. Battery, you have to do something, and you use something called differential charger, differential converter, such that minimal loss is there, such that the overall losses in any path doesn't exceed more than 7%, in any path, in fact less than that. So instead of 45%, of course battery losses are always there whenever power goes through the battery, you get about 7%. The design is complex, but this kind of system directly powering the DC load. This is the kind of system that is what is called a solar DC system. If you want more details, I have last time told you the IEEE Spectrum magazine has an article in February of 2017, and IEEE Electrification magazine has a more detailed article in June of 2016 issue. Please take a look at it, which will get you more details. We will try to also send them. We will put them in our course pack. Solar DC advantage: solar and DC the grid power can directly power DC load when grid is available, when both grid and solar can charge, and even if grid is not there, solar can power, because battery will supply the rest of the power. Both grid and solar can charge the battery is not full, and during load shedding, solar power and battery power will power loads. Only excess solar power will charge battery, or grid power will charge battery. Highly efficient solar power delivered to load through battery has low loss, 7% even at 100 watt solar panel. That's the point. 100 watt solar panel, very small solar panel, and one can actually do that. DC appliances contribute to energy saving. So this is the kind of system that I'm talking about. We are calling it inverterless. You are used to inverter at your home. There is no inverter, so we are calling it inverterless. Inverterless 500 system designed as an expandable, and this concept any of you can also design. I mean, there's nothing, so this thing, once you understand the concept. So this can power, this is now a product which is available. Now 125 to 500 watt solar, you can connect to this. Grid you can convert 238 volt AC directly up to 500 watt, you can connect to that. You can connect to a battery, very interesting batteries you can connect to, which can connect to this, and output comes 125 to 500 watt DC, uninterrupted. There is also an emergency line that if the battery goes down and grid fails and solar is not there, battery is never goes down to zero. After it goes down to 50%, if it's a lead acid battery, you put it in emergency mode, so that small amount of power is always available. So 2 lines you normally can actually do. So that's the kind of systems that are now used along with DC loads. Now what about DC load? Of course, this kind of system is also monitored using Bluetooth. Soon it will be monitored using GPRS. So on your mobile phone, you can figure out how much energy is being generated at every instant of time from solar, from grid, what is in the battery, state of charge of the battery, and how much load is consumed. Then there are now in products in the market, which are 5 watt LED bulbs, which directly works on 48 volt, cell phone charger and sockets. Remember the socket, look at this socket. These are T kind of sockets. We have standardized that 48 volt DC as a T kind of socket. Why have we done it at a T kind of socket? Because DC, one of the important things, AC you can put the plug like this or you can put the plug like this, it doesn't matter. In DC you can't, plus and minus are very important. So you actually have to put both this and this. So that's the way it has been actually designed. This T kind of sockets has been designed, and so that the right polarity goes in. Of course, you also have a socket which a USB on it, so that you can directly connect it to the charge your phone or any USB charging you can do. You have brushless DC motor fan. Crompton Greaves makes it, and TVS Lucas makes it. Soon there will be others who will be making it. Tube lights, which can also be this. Remote control for fans and all that. And they don't cost too much. For example, the solar panel of 125 watt plus 1 kilowatt hour of battery plus a LED bulb plus a socket plus a fan plus a tube light, all of that cost under 20,000 rupees. That's a kind of thing that are now starting to get available, not yet fully commercialized, but soon will be available more. You have other things like DC coolers, desert coolers. You have, in a dry climate you can use desert coolers. Haryana, for example, you can certainly use desert coolers. Now these desert coolers, example, AC desert cooler consumes about 180-200 watt of certain size. This consumes only 80 watts. Why? Because you are using DC motors again, and directly powering using DC 48 volt. Similarly, televisions, you directly connect, you avoid the AC to DC converter. So for a 24-inch color television, it consumes with the set-top box only 30 watts. You have things like DC mixer, consumes 150 watts peak instead of 350 watts. So more and more DC appliances are coming in, refrigerators, stoves, all of these one are starting to work, and they have been deployed in large scale. For example, in Rajasthan, in desert area, in Jaisalmer and Jodhpur bordering Pakistan, these are desert areas, vehicles cannot go, only tractor can go or camels can go. That's a place where individual homes have been all connected. Some 4,000 homes were connected. Similarly, in Assam, on the hills, it was very difficult to reach there. Grid doesn't go there. Off grid, solar, there is no grid, and homes have been connected. Something like 4,000 has been connected, and more are being connected. 105,000 lines are being connected in Assam and in Bihar in using UDC. And this is a typical profile. This is a typical profile in Rajasthan. Rajasthan, there is no cloud at all. So solar starts, if I look at it, it starts around 9 AM in the morning, or 9, 10. The solar goes on till around 6 PM, till around 6 PM. The consumption is this much, it's going flat like this. Battery is charged during this time. This kind of thing can be available on a mobile phone, and from mobile phone it is relayed to a server. So the monitoring, understanding of use of solar power, losses and performance, there is on mobile phone you can actually find this out. What is the battery power, solar power and load power? Customer is able to figure this out. This is possible using inverterless. In grid connected system, no reverse feeding for small system. Small system, 100 watt, 200 watt, there is no reverse feeding, but we can actually figure out exactly what is going on. This is the actual data from one of the place, Bhumiji Ka Gaon, Jodhpur, from 9 AM to 5 PM on 2 successive days. So that's July to 2016. I think these are data of 2016. So this is a data. These are typical deployments. In many of these places, there are no, they are thatched homes, and on rooftop it has been all connected. If you see, lights have been connected. This is the way the local technicians were powered to do that. In fact, in number of places, in recently last week, 2 weeks back, we actually did it in Karnataka, in Belagawadi. We have done earlier in Trichy, in near Trichy, in a village. Nilgiri we have done it, and Trichy we have done it. We are doing it in Telangana. Number of places these have been deployed. If you ever come to IIT Madras, any of you should see it. Really a very, very interesting systems, and it is being deployed. And of course, villagers are very happy. First, many of them have seen lights for the first time. For example, there was a woman who mentioned there that she had never seen electricity in her life, and she was around 45. She had never seen electricity in her life, of anything electricity, and how the whole thing is being done, and schools are being connected, homes are being connected, and it makes a huge difference. There is one more alternative. If sometime you can put 500 watt, and there may be a cluster of 4 homes nearby, and each of those 4 homes can be given separate connection, and they can be metered separately, so that no home can draw more power. Complete solar DC. This is the kind of things, versions, and a lot of student projects can be done actually on something enables sharing of solar and battery resources amongst multiple homes. This is what is possible, can power. There are bigger one called inverterless 2500, which can power 12 or 24 homes and slightly bigger offices. So solar DC is equally important for a grid connected home. It gives you solar DC inverterless plus DC power line plus DC appliance. This is huge cost savings, draws less, reduces power bill, provides power backup, free homes from load shedding, of course enables us to use solar in a most cost effective manner, and a 500 watt solar power with DC appliances can make care of most of the essential load in a middle class home. My home has a 125 watt with grid connected, and it is connected to 4 fans, some 8 lights. It has a mixer, television, laptop chargers, cell phone charge. And one of the most interesting thing that took place, I talked about 2015 December, floods in Chennai. There was no power in the city. Some of the homes had grid diesel generator, but even some of the diesel generators were flooded, and even if they were not flooded, they ran out of diesel. So after 1 day there was no power, 4 days there was no power. Whole of IIT there was no power for 4 days. My home alone had power. I have only 1 kilowatt hour of battery, effective uses of half a kilowatt, but I had sun, and even though it was raining, there was still enough sun to keep on adding. And of course I was alone, I was using less power, light, fan, my television for a short time, but my laptop and cell phone, I kept on using it all 4 days. In fact, I did more work on those 4 days than I have ever done, because I was just sitting there, nothing more you could do, couldn't go out somewhere and just work, and I was able to get some connectivity or other, internet connectivity through one of my phones, and so I was able to actually use it. One will say 500 watt is too small. Well, 500 watt is, in fact my home in DC form will not use more than 500 watt hour on the average. Of course, other than air conditioner pretty much. Right now air conditioner, washing machine, my current refrigerator, and a current idli grinder. These are the 4 things which are not on AC. Everything else is on DC. Everything else is on DC. But tomorrow even and also a water heater. 5 things are not there. But a refrigerator can certainly become DC. Washing machine can also become DC tomorrow. Idli grinder can become DC. And my own feeling is that maybe 600, 700 watt will take care of all my load except water heating. Water heating I have not yet looked at it. So that is what is possible. One will say, but isn't it too small? Well, what I did is that we took 500 watt solar panel and we said that 1 watt of solar panel produces about 1550 watts of power in a year. It was taught by Dr. Projot Kaur. I suppose say that all the homes, suppose it has 500 million watt solar panel on the rooftop. What will be the total power produced in the year? And we have calculated and shown it is 190,000 gigawatt per year. And the power consumption in 2015, data is available, maybe 2016 also, we'll get it soon, was equal to that, less than that. So 500 watt solar panel on every rooftop can generate all the power that we require for all our homes. And we can of course add offices and things like that. So I've just talked about in off-grid home to provide power for DC appliances. This is something that I've already done. It can be used in off-grid home, it can be used in grid connected homes, makes immense financial sense, and apartment and cluster for 4 and 12 and 24. Let me take a few minutes more. Question is, why did we choose 48 volt? We debated quite a bit. We started working with 200 volt. The reason we wanted higher voltage is because if I use higher voltage, for the same wattage, my current goes down. If current goes down, my wire thickness goes down or wire losses goes down. But we found that 200 volt DC is not very safe. Then we started looking at it, anything below 60 volt is considered safe. And after a lot of debate, if it is a 60 volt is called safe extra low voltage. We said we will fall below that. 48 volt, but it will vary by 3, 4, 5 volt plus minus. Battery can go up to 56 volt. We sort of said 48 volt is good enough so that battery doesn't exceed 56. We still have a little bit of margin and it's a safe voltage. Essentially 48 volt you touch, nothing happens. In fact, your telephone line at your home for a landline uses 48 volt. It comes and you often touch it. It doesn't really matter at all. 48 volt is considered safe. That's one of the reasons why it is chosen. We looked at whether we should use 12 volt or 24 volt. Two problems we found. 12 volt, etc. Fans become not very efficient. Motors become very inefficient. But what is more important? What happens to the cable losses? Suppose I have the same wattage. Instead of 48 volt, I go to 24 volt. Decreasing the voltage by a factor of 2. My wattage is same, my current will go up by a factor of 2. When current goes up by a factor of 2, my losses is I square R, losses in the cable, I square. So losses go up by a factor of 4. So if I go to 24 volt instead of 48 volt, my losses goes up by 4 times. What happens if I go to 12 volt? 12 volt is 1/4 of 48 volt, my current will go up by 4 times, my losses, power losses will go 16 times. So essentially makes no sense to do 12 volt and 24 volt. 48 volt, in fact the existing wiring that we use at our home 1 square mm, 1.5 square mm and sometimes even 0.5 square mm is adequate. You can actually use that because your wattage has gone down. So in fact for my lights and fans I have not changed my wiring. I have used the same thing. In fact today what we are doing in many homes that we are building at IIT, we are using 48 volt and 48 volt has been used in telephone line, telecom and all that. So what we are doing is 48 volt DC power line we are using. 48 volt power line we are using for, you remember that our homes typically have two power line, what is called 5 ampere line and a 15 ampere line. 15 ampere line is used for air conditioner and for washing machine and things like that. 5 ampere line is used for rest of the things. We are converting the 5 ampere line into a 48 volt DC line. 15 ampere AC line continues. So this is the one of the stories. Home or tomorrow will run on direct current. There one of the stories you can look at it. 48 volt DC line is the future. So this is solar DC inverter is the future of grid homes. This is something that we wanted to talk about. Before I end this lecture, I want to talk about one more thing. UDC innovation. There is another interesting thing that we worked on. You know, the question was, yes, but we are talking about changing all the appliances to DC. How do you attract people to change to appliances? There is still not a standard. So we came up with this concept of UDC. What does a UDC do? DC power line at home, all the technical and financial reasons why DC power line makes sense today. But to these, one requires a market push. It is new, not tried out, fear of moving back. Many people say DC was old, 150 years old. DC powered appliances are still not available. Though they are internally DC, there is a built-in converter AC to DC. Not enough maintenance people, not sufficient standardization. Also, addition of rooftop DC makes a lot of sense. Losses are curtailed, investment quickly pays, but would require market push. So we sort of said, but how do I make it attractive? How do I make sure that people like it? A market pull. And we came up with the idea. Suppose, in addition to the current power line, every home had a 48 volt DC power line. Suppose I give them two lines and give them an option not to use or use it. While 230 volt line remain as it is, 48 volt line is also available. Well, line is at the meter output, so home is free to use it. So that will help, that will at least help, well, people will find it easy to use. But still, DC appliances are new, they will consume less power, but they are new. The people may still hesitate and people will add solar, but probably not yet. But suppose I do an innovation, and that's what a UDC innovation is. Suppose I say that whenever load shedding takes place, your AC line may go off, but DC line will somehow remain. If DC line remains, then it becomes uninterrupted line. If I give uninterrupted line, lot more people will be interested in it, because they are getting from the utility itself, from the power distribution company, uninterrupted line. It's a low power line, but even that low power line, 48 volt DC, will say, well, it's good if I can buy even one fan and one light, at least that will be on all the time. And that's what UDC does. How do we make it? Do we put battery? No, we don't put battery. We try to do a unique thing with load shedding. What is load shedding and why does it take place? Load shedding takes place, a DISCOM does load shedding when power available is less than the demand. And therefore, in certain areas, distribution areas, they say, let me cut the power. That's what load shedding is. So, we have created a market pull by, suppose I give an uninterrupted line. Wow, DC power line by DISCOM is uninterrupted line. I'll at least buy one fan and one light to begin with, saves me power, and then gradually I'll display it. But I keep adding, limited DC power line may still be a problem. I'll say I want more of that. Well, that time I'll say add solar DC, because you already have a DC power line, you're used to now DC appliances, add solar DC. So that's the thing that we really thought of, we could create a market pull. Now how does it really work? You know, today at your home, if I look at your home, what happens? There is a 33 kVA line from the substation, it is put on a transformer to 11 kV line. 11 kV line comes near your homes, 11 kV line. And 11 kV line is put to what is called a distribution transformer. There will be probably one within 500 meters of your home, a distribution transformer. A distribution transformer is mounted on the street. That distribution transformer will give me a 230 volt. It may give me 3 phase, but I can take any one phase and take it to the home. That is the power distribution that is done today. So this line would have given you the AC line. What I do is that I add what is called a UDPM, uninterrupted DC power module. But uninterrupted power I'll come to in a minute. What I do is that I put in a small DC to AC converter, let's say for 100 watts or 125 watts. This will be the DC line. So the same line without any change will also give me a DC line and AC line. So that is good. I am getting a DC line, so I don't have to do any conversion. I'm getting it, I can use it, use DC appliances. But it will still require, how does it give me that this becomes uninterrupted? When power fails, this will also go off. So that requires a little bit of change, and that is what the UDPM innovation is about. What we do, suppose power fails, whole thing goes off, unless I do something else, and that's what we do. What we do is that we make a small change at the substation level. At the substation level, we introduce a concept called brownout. Brownout is when the power, when the load shedding takes place, AC line will be cut off, but DC line will be retained. How do you go about doing it? You take this 33 kVA, you take this and you step down, instead of to 11 kVA, you step down to 4.4. You step down to 4.4 kV. So lower voltage, and you switch. Normal situation will be 11 kV, brownout situation you give only 4.4. 11 kV or 4.4 kV both will go to the distribution transformer, and 11 kV line when it goes through distribution transformer will give me 230 volt. But a 4.4 kV will give me lower voltage by 90 volts, approximately 2.5 times lower. What you do is you design your UDPM that whenever it sees 230 volt, it will give the AC line as well as DC line. That's a normal situation. Whenever it sees a 90 volt, which means the brownout. Now I don't want AC to be turned on. You switch off, cut off AC, but keep the DC line on. Now what happens? Since the DC at any home will only draw 100 watts, you are essentially saying 100 watt I will guarantee. But of course in DC form, since I am using in DC form, now 90% of the power I am cutting off because the AC line is going off. 10% of power I am allowing it to flow because this is the DC line. And your lights and fans, minimum number of lights and fans, and some electronics will continue to work. This will now introduce customers to use DC power line at appliances. As DC becomes more and more acceptable, this will not be required. You can just directly use inverterless and will make things easier. When limited power provides by UDC gets exhausted, we'll be adding. To sum up, solar DC is a way to go. Have a DC microgrid at home, have solar and battery directly connected to DC power line. use DC powered energy efficient appliances will save huge power and significantly enlarge energy. I have just told you UDC will help you create a market pull towards this solar DC. Will also provide you 24/7 power. Of course, if you use an inverterless also, if you are directly using inverterless, then you don't need UDC. But if you don't, UDC can be made available to everybody. This is what I wanted to present. I think I will stop here. First, I will quickly ask you 2 questions. Kerala College, I am seeing. I am going to ask you 2 questions, one after another, and you have to answer by raising hand. First question: how is inverterless solution better than existing solar AC system? First answer is avoids AC to DC, DC to AC. It's a more efficient system, highly efficient when dealing with low power wattage, all of the above. So I would like you to give me the answer. Which one is correct? Is all of the above correct? D. If you think D is correct, you raise your hands. Kerala College of Engineering. I see 2 hands. No, they have all gone down. So all of the above is not correct. It avoids AC to DC and DC to AC conversion. Is that correct? Raise your hand if you think. Kerala College of Engineering, I am seeing you. Others I am not seeing, I am seeing you. If you think it avoids AC to DC and DC to AC conversion, raise your hand. It does not avoid AC to DC, DC to AC conversion according to you. Alright, is it a more energy efficient system? Is it a more energy efficient system? If you think that is a right, raise your hand. I see 1 hand up. Highly efficient when dealing with low power wattage, and people who think C is right, I see at least 3, 4 of it, 5 of you, and all of the above. You are wrong, unfortunately, College of Engineering. Actually the right answer is all of the above, because it does avoid DC to AC, AC to DC conversion, which is required in solar AC. It is a much more energy efficient system, and it is highly efficient when dealing with lower power wattage. So the right answer is all of the above. Okay. I hope the second question you will answer right. How does a UDC system overcome transmission losses usually found in DC line? Is it by putting new DC lines from substation to homes, or using existing AC line from substation to DT and DC wiring from DT to home, or using the existing AC line from substation to home and having internal DC wiring? The answer D is all of the above. So those of you think A is right. Do we install a new DC line from substation to home? I don't see anyone raising hands, so that's fine. B, using existing AC line from substation to distribution transformer, but a DC line from distribution transformer to home? No. Answer C, using the existing AC lines from substation to home and having internal DC wiring. I see at least, yeah, all of you are raising hands, and of course all of the above is not correct. So this time you are right, C is indeed right. Thank you, Kerala, and I think I will stop my first lecture now, and please ask me questions. Any questions anybody wants to ask, either Kerala or anybody else? Anybody wants to ask the questions, please do that. Start interaction. BC, Suresh. Yes, go ahead.
Go ahead. So the PV panel efficiency is 12 to 15%. So what will be the total efficiency of the solar photovoltaic system design, including all the losses? Because the PV panel efficiency itself is less than 20%, sir. So
can you please? All right, I think I understand. I thought we had answered this question well when Dr. Prajot had given a talk, that the efficiency of solar panel only tells you what is the size of the panel required, what percentage of solar light is converted to electricity. The percentage that is not converted is not wasted. Today all the solar light comes and falls on our rooftop or on our fields. It is not wasted. That gives us life. What a solar panel efficiency says, that how much of the light falling do I convert to electricity? Do I convert 16% or 20%? If I want larger power, I will need a larger, longer size. It only means how much rooftop area do I use. It has no bearing on the rest of the efficiency. A 500 watt solar panel will give you 500 watt, irrespective of whether it is a 20% or 10% or 30%. So it doesn't matter. A 500 watt solar panel costing a certain amount, or a kilowatt of solar panel costing about 35,000 rupees will give you 1 kilowatt during peak sun. So it doesn't matter whether it is 16% or 20% or 30%. That efficiency only says efficiency of use of ground area. And it is not that the sun power is really wasted. Remember, when sun power falls today on our rooftop, it doesn't get wasted. It gets converted to heat. It actually is a source of life for all of us. So that power is never wasted. So this whole concept of solar efficiency, solar roof efficiency is only in context of the amount of rooftop area that you used, and what you are asking is not valid. What I am talking about efficiency is, after you generate solar power, is it dissipated into heat or is it used to use electricity? When I am saying 45% of power is lost in a solar AC system plus 10% is lost in a battery, that 55% energy is wasted in heat form. It is just electricity is generated and then wasted. Electricity is first generated and then I square R losses it creates. I square R losses. That's the waste. We are only talking about efficiency from that point of view. Whereas in solar DC system, only about 7% plus of course the losses in the battery gets impacted. I hope the answer is right. Otherwise you take up the question again in a, please go through the lecture on L2, I think L2 or L3 we dealt with this whole issue. Go through that again. All right. Suresh, fine. BEC. Okay. So I am now connecting one more college. Satpal, can you please ask the question?
Hello, sir.
DCRU. DCRU.
Sir, what is the difference between grid tied and net metering and grid connected plant?
Okay. So net metering basically says that the power that is generated, if I don't use the power, I can feed it back to the grid. I can feed it back to the grid. So you, instead of taking power from the grid, you are actually feeding it to the grid. And net metering says sometimes you will be using power from the grid, sometimes you are feeding it back. The net difference is what you are billed at. So that's called net metering. It makes a huge sense to do that if you have a large solar panel. If you are generating 25 kilowatt solar panel on your rooftop, and if you are not using all the 25 kilowatt, you can feed it back. For a 500 watt or a kilowatt, it makes no sense. So many independent generator on the grid will in fact impact the grid very negatively. It may have a very negative impact. So small homes having grid tied inverter with reverse feeding is not desirable. I have just ruled it out and not dealt with it. Okay. All right. I see again. BEC Suresh again asking me another question. Go ahead.
Go ahead. What efforts government is making to providing loans for solar rooftop systems?
Well, government has whole lot of schemes. MNRE has whole lot of scheme. Solar DC still they have not yet popularized. Soon they will hopefully popularizing solar DC. They have a whole lot of scheme to promote solar by using subsidies, and there are some state government schemes also. MNRE, if you look at their website, you will get them. Solar DC is still not used effectively. Hopefully it will be used soon. What should be the, I see some other questions by some other people. What should be the capacity of the generator if you are using this and when the grid fails? Well, you have to calculate what is the power that you are going to consume. If the grid fails, either solar will power your load or battery will power the load. So you have to calculate what is the total power that you are consuming. You of course can measure it, but you can calculate what is the maximum power, number of lights, number of fans, and your battery and number of hours of grid will fail. Based on that, you will have to design your battery size. Not capacity of the generator, but should be capacity of the battery. Sir, could you clarify even the concave solar panel is having higher efficiency? Well, you know, some of this concave solar panel tries to concentrate solar power and put it into a place. You can use it, but it doesn't save you the rooftop space, because finally you have to capture so much and then try to bring it with a smaller solar solar panel. So the solar panel cost will go down because it is a smaller solar panel, but the cost of the concave lens will go up. So effectively it doesn't help you too much, it helps you a little bit, not much. Why are we preferring solar panel only, planar solar panel only? Because least cost is the main reason. Today I have told you that cost per watt of solar panel is only about 25 cents, 27 cents. Actually in small quantities it is higher, more like 35 rupees per watt, but even then the cost is cheap. Anytime you go for anything else, the cost will become very high. I see some more questions. What is the potential available for rooftop system in India? As I told you, if every home has 500 watts, we will generate all the domestic power that we need. Satpal has a question. I was wondering why Satpal so quiet today.
Good morning, sir.
Yes.
So, what is the theoretical efficiency of silicon-based solar cell?
I have in a class in L3 we have discussed this. Silicon solar efficiency today, what is available solar panel efficiency is as high as 30-32%, but if you do not use silicon alone but use all other things, you can go as high as 45%. Remember, there was a chart that was shown. Today I have not covered that, but that efficiency has of no consequence. That efficiency will only say what is the rooftop area that you will occupy. That efficiency does not impact, it is not losses. Losses that today we talked about was due to AC to DC, DC to AC converter and wiring losses. Yes, you have a question, rather Satpal? If you have a question, please go ahead.
सर, अगर हम 150 वाट का पैनल रूफटॉप पे इंस्टॉल करते हैं तो उसके लिए हमें कितनी कैपेसिटी की बैटरी यूज करनी चाहिए, और अगर हम उसको यूज नहीं करते हैं तो उसके क्या परिणाम सामने आ सकते हैं?
तो 150 kilowatt panel, what we do is, I have 125 watt solar panel, I use a half a kilowatt hour of effective battery, because in a day 125 watt of solar panel will give me half a kilowatt hour of total energy. So I use half a kilowatt hour of effective battery. Now lead acid battery you can only use 50%. So actually what I use is a 1 kilowatt hour. If I use lithium ion, I will probably use 650 or something like that. That's what is commonly used for 125 watt, because you store 1 day's energy. If you want to store 2 days energy, all the solar panel, you may double it, but I will sort of say 1 day energy is more than enough. Okay, what I will do, I have sent you assignment. Assignment is already there on the course pack. I hope you are looking at it, tutorials, and today I am going to actually take some of the problems in tutorials and start solving them. In this I will talk about new installation in off-grid home, then in new installation in connected multi-storied complex, both mid-income and high-income, then retrofitting existing mid-income homes from load shedding. So there are 3 different problems: off-grid problem, multi-storied complex, and retrofitting existing mid-income homes, changing inverter to inverterless. For each one of them, the tutorial has one question asking you to design a system and do a computation. They are slightly difficult questions. It will require you to use Excel sheet extensively. What I will do is that I will solve one of the questions and give you results of the other question. The Excel sheet is also put on the course pack. It is put along with the assignments. So please, if you really learn this, solve these problems, you will become very good. So try looking at it and try to understand that. New build for inverterless. Suppose there is a new building coming up and I'll start using inverterless. Economically obvious for all new builds. For all new builds, using a solar DC 48 volt system makes immense sense. Replace the 5 ampere line with DC appliances. It is far more cost effective. We'll calculate the cost of it. Solar to the extent possible on the rooftop is economical. Battery backup when load shedding is likely. Can use a small backup AC power for legacy appliances like some washing machine or grinder. Small increment in capex saves power bills immensely. That small increment in capex also is going to go away as the volume goes away. So use 5 ampere DC line, 15 ampere AC line. This is obvious, and whenever somebody wants a old apps, let them connect 15 ampere plug, dual plug. They can take both the small plug and large plug. So that's the way new buildings are done. Our new buildings in IIT are built using this. Retrofitting home, having load shedding, replacing inverter with inverterless, maybe wherever the battery needs replacement. Whenever a battery needs replacement, that's the time you should look at whether you should get a battery or should you put inverterless. Solar will always help, better investment than keeping money in the bank. Spend 25,000 rupees or 50,000 rupees on solar and you will get a certain return from the bank. Even with fixed deposit, you will get about today's 7.5% return. Remember, you have to pay tax on it. If you deduct that, your return is not going to be more than 5%. Whereas with this, if you put it, your electricity bill will be saved to the tune of about 12 to 15%. So it's a much better return on investment. Appliances replacement cost recover in a short time. Okay, you will replace appliances because you have to put DC fan, DC lights. So first year there will be a little bit, but within a year you will recover all your costs. And if there is a higher load shedding, the recovery can be even faster. Before we begin to solve the problems, list power consumption of AC and DC home appliances and the costs. Understand typical usage appliances. Now, your answer to the question will depend on how much the appliance usage is, and we will put all of them in Excel sheet. Losses in different scenarios and power cost for different scenarios and load shedding, duration and usage. So these are assumptions I am going to make. First assumption that I will make, a fan. Look at the fan. I can use AC fan or a DC fan. AC fan can be operated on speed 1, 2, 3, 4, 5 and will consume 60 watts, 63, 66, 69, 72 watts. DC on the other hand will consume 10, 15, 20, 25, 30. This is the cost, 1400 and 1600 rupees for a new fan of AC or a DC. Tube light, I can use CFTL tube light, existing ones cost around 225 rupees for a new fitting, 36 watts. LED consumes 18, 14, 11, 8, 4, you can dim it and cost only about, well, cost has gone down, it is no longer 700, it's more like 500, but I have the old cost. Bulb, AC bulb cost, it consumes 40 watts and cost about 60 rupees, LED consumes only 5 watts, it's equivalent and consumes about 110, costs about 110 rupees. Television, today the new television all comes with AC or a DC. AC one will consume about 40 watts, DC will consume 30 watts. A phone will consume 6.5 watts and 5 watts. A laptop will consume 60 watts and 45 watts. And air cooler will consume 250 and 100 watts at speed 1. At lowest speed it will consume 210 and 25 watts. Based on this and this costing, we are going to do the computation. We will use Excel sheet, put all this data into the Excel sheet. What is the typical usage per day? Well, let's assume there are tube lights. Small house has 2 tube lights, large house has 6 tube lights. Multi-story small flat has 2, large will have 6. Fans, small house will have 2 and multi-story small flat also will have 2, large house has 6. And number of hours they will operate 6 hours and 12 hours. You can change those numbers. Once you put it in spreadsheet, you can change the number and see the impact. Air coolers, large house may have 1, small house will not have. Bulbs, as I have told you. Phones, small house may have 1, multi-story flat may have 2, large house may have 4 of them. Laptops, small homes may not have it, multi-story flat may have 1, this may have 2. Television 1, 2, 1 and number of hours is 10, 5, 4. Now these are assumptions, these can be changed, but I will do computation based on these assumptions. Now what happens when you take grid and directly power DC load? Suppose from grid power is directly feeding to the grid load. There will be about 6% losses because AC is being converted to DC. If I use grid AC and powering AC load, there is 0% losses. So here, this is the only place where AC has advantage, because there is no losses if I directly connect AC loads. Of course, AC loads will consume higher power. Here, there will be about 6% losses. So that's the first thing that I will build into my spreadsheet. Solar panel. What happens if I directly connect to loss? Well, very little losses because I'm not doing any conversion, about 3%. I operate at MPPT, will be about 3% losses. Because I'm going to go through that, there will be small losses. Some diodes will come in between. That will give you the losses. Solar panel on the other hand, if I do through AC, it will have a 3% plus 15% losses. 15% is DC to AC converter and a MPPT and tracking to this. If I connect grid through battery, what happens? Or solar through battery, what happens? Grid, if I connect, I convert and directly connect DC load. This has losses, solar losses is 3% powering. So what kind of losses do you have here in this kind of situation? When it directly connects it to it, it will have losses. I have already told you about 6%. Solar losses will be about 3%. AC loads on the other hand, grid is connected to AC loads. There is 0 loss. This will have a 18% losses. This is summarizing solar and mains without battery. What happens through battery? Grid goes through battery. So if it is DC load, it has a AC to DC converter plus conversion. So losses will be about 15% in AC to DC converter. This kind of and charging of battery. Plus losses within the battery. 10% is losses. Losses through battery is X% plus Y%, where I have taken grid to battery and battery to loads. So that is the losses. About AC power through the battery will be about 25% losses. AC power. If I put to DC loads, but if I connect to AC loads, it is going to have losses here plus losses here. So 15 plus 25%, almost 40% losses. So this is the inverter losses, because battery has 10% and 15% for 2 converters. What happens when solar is powered through the battery? When solar is powered through the battery, this has a small charger, not much loss, and then this is there. The losses are about 10% due to battery plus 5% due to this, all this. It was 3%, now it is 5%. Losses due to battery will always be there, 10%. If I connect AC load on the other hand, the losses are going to be 5%, solar DC, but if I connect through AC load, this will be then powering, but this will be powering AC loads. So there is going to be 5% plus 25% losses, 10% for battery loss, 15% for converter. Similarly, as solar and mains through battery for DC load, if I combine this, grid losses is 15 plus 10% and solar losses is 5% plus 10%. So I am summarizing this. What happens if I do AC on the other hand? The grid losses directly was 0, but through the battery is 15 plus 15 plus 10, so 40%. That's the grid losses. Solar is going to be this loss plus this loss plus this loss plus this loss. So losses will be about 55%. Three converters. 15, 15, 15 plus 10%, 55%. So I've just put all these losses together and I'm summarizing this in a table. So this table can also go into Excel sheet, that if it's a DC system, solar with mains will have this loss, solar without mains is only mains is that. If it's AC, this is the losses, and if it is without battery, this is the losses. So all this is being put together in Excel sheet, and per day, let's assume 4 hours of load shed, total 4 hours of load shedding. This is an assumption, you can change that. 2 hours during sunlight, 2 hours during off sunlight. And load usage, 40% of load usage is during, this is percentage, sunlight, and 60% is in the evening. This is an assumption, you can change these numbers. With these assumptions, the questions that I am going to ask, and the cost of the power, we'll assume cost of the power from grid is 5 rupees. Solar DC directly, because the solar power cost has fallen down, is 4 rupees. Battery adds 12 rupees. So 4 plus 12, 16 it will become. Solar AC is 6 rupees. So that is the cost that we have assumed. Based on this, we will compute what the cost is. Assumption is solar is installed, sun hours, sun supplies full load. Power cost is total power usage plus 1 plus solar to load losses plus solar cost per unit. So this is the way you have to compute this. Put this into Excel sheet. Else if grid is there, grid supplies full load. Power cost is total power usage into 1 plus solar to loss percentage plus main cost per unit. Main cost per unit. When mains and suns are both, main is same as grid. So I am using mains and grid. Mains and sun is not there, battery supplies full load. For off grid, assume solar supplies battery. For on grids, main supplies battery. So the power cost works out to be total power usage into 1 plus battery to load loss into 12 rupees plus 1 plus battery to load loss plus sun to battery loss plus source cost per unit. So this is what the computation for losses are. Based on this, the questions that we are asking, consider a small homes, see slide 7. Build Excel sheet to compute how much will be the load consumed per day per watt in a watt hour, assuming that it is an AC home or it is in a DC home. So do 2 exercises. How much will it cost if it is all grid power without any power cuts? Compute for sunlight and non-sun hours separately. How much percentage of power could be saved by using DC system compared to AC? What will be the cost saving? So this is one of the problem that I have given you in a tutorial. The second part of this, if AC load is fed by the grid alone with battery backup, how much load will be consumed from battery considering load shedding? What will be the cost? Calculate sun hours and non-sun hours separately. What will be the capacity of the battery? Repeat the same using DC load. So this is a comprehensive question that I have asked. And small homes, if the system is solar AC system being fed by n into 125 watt hour solar panel without grid, calculate the usage from sun and battery and total power cost. And if the solar system is DC system with n into 125 watt without grid, calculate all this. And if the solar system is DC system fed by 125 watt solar panel, battery size as computed earlier. So for each of these, we are giving the questions. Now just look at the power consumption and the cost per day. Look at this. And I have taken each of these tube lights. Number of hours is 6, wattage is 36, so it is consuming 432 watts. Similarly, bulbs are consuming 800 watts, phones are consuming 200, it's a small hose, 400 watts. Total consumption in a AC system is 3.4 kilowatt hour, 3.4 units. Per day cost, if you take all of this, all grid is 16 rupee 93 paise, assuming 4 hours of load shedding, 2 hours in the morning, 2 hours in the night. If I do the same system in a DC system, this comes down, my total power consumed is only 1.5 kilowatts, less than half, even assuming 6% losses. My cost comes down to approximately half. If I consume AC and DC homes directly from the grid alone, this is from the grid alone. So if I save, if there is no power cut and power comes only from the grid, I still save 57% of costs. Cost saving per day is 9 rupees 70 paise. 1693 is the cost if it is AC home, 719 cost using DC homes. So even if there is no power failure and no solar panel, still you save about half the power. But let's look at the same thing if I do AC home with inverter, DC home with inverterless. Now with solar. During sun hours, my cost comes to 1345 rupees per watt hour, and load required is this from the battery, this from the grid, and my total cost in a AC home comes to 26 rupees 52 paise in a day if there is a 4-hour load shedding, uniform load assumption, 26 rupees 52 paise. From whatever I have given you, one I just calculated based on the formulas used. For a DC home, same thing, I do the detailed calculation, and this spreadsheet will be available to you in your assignment. It costs only 11 rupees. So just see the difference. 4-hour load shedding, 26 rupees become 11 rupees. Whereas without load shedding, it was 16 rupees and 7 rupees. But if there is load shedding, the 16 rupees become 6 rupees, but the DC home only goes up by small amount, 11 rupees. Now let's take solar AC off-grid home. Power that is consumed non-sun hours. Overall, this is the power consumed per hour load, and what we did is that the cost goes up to 55 rupees. If I put a solar AC system, 4-hour load shedding, cost goes up to 55 rupees. What happens if it is a DC home? The cost does increase from 11 rupees to 17. Okay, this is in a small home. I have done it. So AC home solar plus 125 watt plus battery. I have again calculated cost overall, load consumed, and per day power cost from solar plus grid. It comes to 22 rupees. Battery charge for grid for from grid 4 hours of power. And similarly for DC home, it is only 8 rupee 59 paise. It's a lot of exercise, but go through it, give you. So what I am talking about, a small home, this is a summary. If I take AC home with zero load shedding, a AC home will cost 16 rupee 93 paise, DC home will cost me 7 rupee 90. If I have 4-hour load shedding plus solar plus, so suppose 4-hour load shedding and no solar, this will cost me 26 rupees, this will cost me 11 rupees. But if I have 4-hour load shedding and solar, this 26 rupees will cost me 22 rupees, this comes to 8 rupee 59 paise. If you see between this and this is a very, very different difference. Even 4-hour load shedding doesn't. If it is a completely off-grid system, and this should have come in the end, it will cost you 56 rupees. And so if you see the great advantage that the solar DC is. Challenges is 48 volt DC to 230 volt AC, 150 watt inverter with 95% efficiency at 1000 rupees BOM. It's a very difficult thing to design, and this is one of the challenges that I'm putting. 48 volt to 12 volt DC, 250 converter with 93% efficiency. These are difficult problems which if you think you can solve, you can do it. Well, my second question which I'm going to just ask you is, for a large household, do the same thing that I have told you. Build Excel sheet to compute load consumed in AC home, in a DC home with 1 kilowatt hour solar panel, and this is the kind of result that you will get. In a large home, the cost per day with no load shedding, a place like Bombay where there is no load shedding, it will cost you 62 rupees. DC home, it will cost you only 20. But if there is a 4-hour load shedding and solar panel, this cost goes to 87 rupees. This goes to only 31 rupees. So it's almost, solar gives you almost as if there is no load shedding, grid equivalent, even when there is a power backup. On the other hand, in an AC home, if I take load shedding, the cost goes to 97 rupees. So if you really see per day, this is the cost per day. You have to multiply it by 30 days. I think pretty much this, I think I have a similar result for residential complex with 12 flats. I'm just going to leave it to you, and a very similar result. If you see with AC grid, no load shedding, 18 rupees 56 paise per day, but with 4-hour load shedding is 29 rupees, but with solar DC, this improves like anything, 8 rupees 73 paise and 13 rupees, pretty much that. So these things I have just more given to you. Those of you are interested, these questions are there in the tutorial. Your teacher can try to, we'll give them completely all the solved spreadsheets to the teachers. The teachers want to get you to understand that. It's a little more complex, but I understand most of your students are master students. It will be great if you can learn this. You would have really understand technical, and I know I've done it fast. This tutorial is somewhat tough, and as per your requirement, I should make a easy questions also. I have not done it. My mistake. I should have done some easy questions also. This is a change that we have to do whenever we teach next. Some easy questions. These questions will require you to do spreadsheet, learn and do. It's not easy questions I've avoided. That's something that I have to do. Satpal is asking me some questions. Chandigarh, no, it's not Chandigarh, Haryana. Go ahead.
So, how much time we will get to solve this assignment?
How much time will we get?
To solve this assignment. And when we have
that
to submit
depends
it?
totally on your teacher. We will, there is a 1-day exam also, what? So it will be for 15 days. It will open from today to 15 days, 15 more days. If you want, you can extend it. 15 days. We will open from today to 15 days. Yeah, it's nearly end of March. So we will open today to 15 days, 15 days from now. Okay?
Okay. So can we get these PPT or these slides?
Yeah, they are there on the course pack. Please look at the course pack. There is a question, will there be any issue of using simultaneously for load while charging? There is no issue. You can be charging as well as using the load. No problem. In the designs that we have done, there is no issue. There is a question, what is the potential level from rooftop system in India? I have already answered that. The cost of DC fan is much higher. Well, it is today higher. By next year, it will fall down more or less the same cost. In 6 months, it will be roughly the same cost. Satpal again wants to ask some question. I am giving to Satpal again.
So can you hear me?
Yes, very clearly. Yes.
So as you told us, there is a 33 kilowatt supply from the power station in AC case. Then there is 11, and then we reached around that is 230 to 240 kilowatt. What will be in the case of DC?
No, so as far as the power distribution is concerned, it will continue to remain same. There is no change that we are protecting. Only in the place where we are putting UDC, uninterrupted DC, that will only done in a very select places, where in a normal situation it will be 33 kV, 11 kV and 230 volt. In a brownout situation it will be 33 kV, 4.4 kV and 90 volts. This is a voltage. In a UDC, we are doing this in Sasaram and Lakhimpur in Assam. This is not being implemented elsewhere. When DC is directly put at your home through solar DC, through inverterless, grid doesn't change. Grid remains as it is. All right.
So, as you told in your first lecture that from Delhi to Nepal there is a high voltage line is transferring from Delhi to Nepal. But you told us there is no experiment has been done for the small voltage. So how can you say that?
The Delhi to Nepal is a high voltage DC power line for very high capacity. I don't remember how much power, but it will be in hundreds of megawatt. Distribution side, the one that I am talking to, there are two things that I talked about. One is a inverterless, another is in UDC. The two are very distinct things. In inverterless, no change takes place in the grid. It is only connected at your home. It is connected at my home. It is connected to, I told you 15,000 homes now. That is done totally within home, solar panel and inverterless is connected, and that's how it is being given. In two places, UDC trials are going on. UDC pilots are going on. UDC pilot, yes, in the grid, there is no DC going, still AC only, but the voltage, normal voltage is 33 kV, 11 kV and 230 volts. Brownout voltage is 33 kV, 4.4 kV and 90 volts. That is all AC. At home it is converted to DC. In distribution line there is no DC, even in UDC. Alright, is that clear?
Yes, sir. Thank you, sir.
Okay. Alright, I think we have covered. There is no other question, looks like. Sir, why battery will self-discharge without load? Well, the batteries are chemical battery. I mean, the ions are supposed to be separated. But you know, in a battery there are chemicals and they will interact. So slowly there may be a self-discharge. The discharge are typically not more than 1 or 2% per month, maybe 3%. So it's not really very severe. There will be discharge. We cannot say there should be zero discharge, self-discharge. Lithium-ion battery have very little self-discharge, and so is lead acid. It's not much of an issue. Of course, if you keep it for several months or a year, yes, there will be discharge. But then battery is not designed in a rechargeable battery. In a one-time chargeable batteries have much longer life. Their discharge is even less. I think with that, it is 11:43. I hope you have learnt something in this 5-6 hours. Do ask me questions on email in case you need to. I will once again give my email address here on the board. And of course, you can look at the course pack, and there is also a in the associated course pack there is a forum in which you can ask questions, but you can also directly ask questions to me. I think with that I am going to stop and end. Is there a question there? Can I see that? What is the potential available from rooftop system in India? I have already answered that question. Is there any internship program on this topic on course pack? Course pack will not have internship program. The course pack will have all the lectures and will have all the tutorials, and course pack is a material on which all these things are available, including my lectures will be available. I think with that, thank you very much for the 5.5 hours. I hope you have learnt it. You, as I told you, you can connect with me in future if you want to. Thank you. you.